But at this point, I want to move on to the presentation from Roland Koval, who's going to talk a little bit about some of the initiatives under Objective 5.3. And so for those of you who've never met Roland, Roland's an ecosystem modeler with AAFC out of the Lethbridge Research and Development Center, and his work revolves around development of AAFC's whole form model called Holos. And so if you're not familiar with Holos, this is a software application that estimates greenhouse gas emissions and changes in soil carbon in Canadian farming systems. And the model development focuses on enhancing environmental sustainability of Canadian farming by testing, validating, and providing sustainability attributes for the Canadian agricultural production system. And so one of the goals with CAF is to hopefully incorporate some simple metrics from all of the science that we're doing to build this in to the Holos model so that agricultural producers can actually see what having wetlands and the management of these wetlands on their farms means in terms of the greenhouse gas balance at the farm scale. And so with that, I'm going to hand it over to Roland.
Thank you, Pascal. Okay, Tamik Fisago. I'm greeting you in the Blackfoot language because I'm talking to you from Sikokkotok here in the heartland of the Blackfoot people. Yeah, it's not easy for me to follow up on Doug because it's always a little bit of a stretch, basically, to say that the Holos model represents the national inventory calculations, even though we're aligning with the actual calculations as much as we can. But also then to say we might be able to provide some help, but as I will get to, it's going to be probably a future vision of that. So just quickly, I think most of you have seen this already, but what is the Holos model? Basically, it's an attempt to provide a tool to farmers to do a whole farm analysis to basically look at the questions of what are my emission sources on the farm. And in this context, we're trying to follow essentially the national inventory approach by saying there is an agricultural system that has direct sources of emissions that come out, and those are quantified with IPCC Tier 2 emission factors that are used in the inventory. We're trying to do this as open and as reliable as we can, and this is basically then the reliable is basically then to try and align with the national inventory as much as we are able to. But however, we do step a little bit ahead of the inventory on the basis of peer-reviewed science, because we get the farmer to input information directly or whatever user chooses to use the model. And so a number of practices can be incorporated in the Holos model that the inventory would have trouble to incorporate just because, and Doug made the point about the activity data that are just not there at this point. However, we're trying to use some of the approaches that we utilize in the Holos model then to inform updates in the farm management survey, so that again, some of the work that we're doing ultimately finds its way back into the inventory. So just quickly, kind of this is essentially what the model does. It calculates nitrous oxide, methane, both the nitrous oxide indirect and direct. We do basically look at the CO2 exchange. The biogenic CO2 exchange is represented through essentially soil carbon modeling and the changes in soil carbon stocks. And there's some direct CO2 output that need to be refined further, but basically they are as good as we can make them right now. And then maybe for Gail, there is basically in the model these upstream emission estimates in there for the if people want to do kind of a carbon footprint analysis of an agricultural product. But the problem is there, if you do a carbon footprint, you need to delineate your agricultural system, and it's not per se a farm, but it is a fraction of the farm that is geared towards providing this output. And then ultimately the carbon footprint is a GHG intensity or an efficiency. So you can improve it both by lowering your emissions, but also by increasing your productivity. And so that's something we've basically found out with the Canadian beef production industry, that their carbon footprint has improved considerably, but it hasn't actually done anything to the emission patterns. They just got a lot more efficient in producing beef. So I just want to quickly touch on the questions, say what is it that we do, and I missed essentially introducing my team, and I'll switch back. So basically we're 4 people. Pam Mental is our data technician. She does a lot of quality control and just checking that the algorithms provide the output that they're supposed to. And currently she is writing up the water budget model. Aaron McPherson, our software developer, he is doing all the coding, and if you play around with the model, basically it's been coming out of his hands, and with the help of several co-op students. Dr. Sarah Polk, some of you have met her already online. She is our model developer, so she does a lot of testing as well, and then development in the algorithm document. And me as the lead, I'm basically doing a lot of talks, informing people about the model, striking up collaborations, and try to inform development needs and data collection needs, and make sure that the team has the money it needs to function. So what we do currently and are involved with is basically we are working with 11 living labs and support their reporting requirements, say, because as they are focusing on agricultural climate solutions, the project deliverables is that they do provide an estimation of GHG reductions. And a lot of the living labs that started chose the Holos model to do their reporting. And so what we then do is support them in their modeling, because of course it's always hard to have a model that fits every farm system and every practice that takes place on the farm. So there's a whole bunch of troubleshooting that's needed to explain, like, yes, you can represent this practice this way, or no, it's currently just not in the model yet, and it's something that we need to develop later. And then the idea is basically that since the model tries to copy the inventory calculations and kind of build on that then down the road, this can help and inform improvements in the national inventory. And we have made some of that already the case. We work with multiple Canadian universities on model training, so basically using the Holos model in the classroom. And if you're interested about this, then please reach out. We also support a number of students that then use the Holos model in their thesis to kind of take an experimental setup and represent it in a whole farm context. We're working with some government branches. So in this case, there's some people in programs branch that use it, but we've also been sending, for instance, our algorithm document to the carbon credit group at ECCC. And I think they basically use then the algorithm document to define some of their protocols that are putting out. There's a number of producer groups that are interested in using it. And again, there's training, troubleshooting. We are working with Farm Credit Canada as well as the Royal Bank of Canada, and they sometimes come with very detailed questions that then take us a week to sort out and figure out, like, how do we respond to this? And then last but not least, there's international collaboration as well with Ireland at this point. So you can imagine the 4 of us are quite busy. This is the links basically for the download page and the open source GitHub repository. There will be a QR code later, so let's skip over this. So here's basically then what is going on currently as we're finishing up version 4. Aaron is currently working on an open source interface, because on the GitHub repository right now you only have the calculation core. And with this open source interface, we're attempting to make the model available to macOS computers. And that's been a question that we've gotten since basically I started in 2012. The water budget model that's published And so on the basis of the publication, now we can put it in and do some water, basically permit some water planning, and then hopefully also, again with the LCA people in mind, maybe also do a water footprint. And we do already know that the the manure handling system that we put in kind of needs further improvements, that we just had to stop at some point to say version 4 comes to a final point. And then due to the Living Lab involvement and their need to report on their emission reductions, then there's a number of beneficial management practices that ideally we would need to include in the model. So that is all stuff that we can do through the power of our own muscle and brains, even though it's a lot already on the to-do list. But that then means basically there's other goals where we can't do this on our own. And so one of those things was the shelter belt component. This was built basically off the 2 AGGP projects that the U of Saskatchewan ran, first under Ken van Ries and then Colin Larocque. And we work very closely with Behan Amichev to then essentially establish the shelter belt component. So without Behan, this wouldn't happen at all. And so I think the shelter belt, even though the model for the shelter belt that we developed isn't incorporated as is into the inventory, and Doug, please correct me and interject if that's wrong, but I think what it did at the very least is it's inspired the inventory to say, okay, is there a way how we can account for the shelter belts? And I think the allometric equations that we have in the model are actually utilized there. This is what I'm gleaming from Aru's presentation just recently. And I think it's still a work in progress. So I don't know where we'll end up with. And this is part of the problems, say, where my promise to say what we input into the model may end up in the inventory. Yes, this opportunity is always there, but there's a good likelihood that whatever we publish will just be the basis for a NIR methodology, because the activity data and availability may change the assessment, where we can say, oh, we can ask the farmer what the wetland looks like, but if this isn't available in a national data inventory, then the NIR couldn't use the very same setup that we use. So this is basically then the case with the wetland. Again, it's something, I think the honor goes back to Chantal Chisen, who asked me at first, like, can the Holos model do a wetland? And it's like, well, no, there's no wetland in there, but could it? Yes, certainly. This all led to discussions with Christy Morrissey and Angela Bedard-Horn. Then the call came along from Environment Canada, and then Irina basically took it upon herself to actually pull a project together and put it in, and luckily we're successful. And so thanks to Irina and Pascal for keeping the push alive and making this happen. But so this is basically the point at where we're now. The project says we are adding a wetland component. I think automatically from the setup of the model, we presume that this focuses on managed wetlands, even though there is probably kind of a unmanaged wetland option, so to say, also in there. But the idea here is to say, if we can put it into the Holos model, then with the premise to say the land user or the land owner can actually be provided with management options for the wetland that may have certain consequences. So what could then a wetland component look like? This is basically how we look at currently kind of an ag field and the type of information that we're looking at to gain from the user. And all those are not really wetland related, but and also basically the point here, like with the shelter belt component right now, we're not actually capable of placing a shelter belt on a field because we don't know how the shelter belt interacts with the field. So the shelter belt basically sits here, and this is likely the same thing going to happen for the wetland to start with. But the idea is then basically to at some point down the road say, well, if you do have a wetland, you can add it actually to the field. And so then here the question becomes basically what is the actual size, because it's part of the field. So how much of the field is a wetland, and what's the permanence? And then we could add in, and David showed one of the wetland pictures yesterday that kind of seemed to represent this quite well. And I don't know whether you would say on that one, you could see the water surface and a little bit of a green strip around it before the crop field started. And so this may have been like a zone 1 and a zone 2, or just a zone 1. But essentially, this is basically the plan for the Holos model user to say you can play around with the zones that you're adding. And in these zones, you may have different options of management in terms of like what type of ground cover do you have, or what plants, and how would this potentially influence the soil carbon change in the soil. All of this basically then again going forward as a kind of vision for the inventory to say once the case has been made that managed and unmanaged wetlands have to be differentiated, then to provide basically management options on the managed site that then could say, oh, actually there is a way to encourage carbon storage or to manage emission patterns that are coming out of this. The basis for this then essentially becomes the point once it is in the Holos model, the model of it can be published. And once it is published, then there is a methodology that the NIR could pick up and then basically change and fit to the NIR calculations. And so in this case, then again, it becomes the question like, could it be a one-on-one where the NIR just basically adopts what we have, or is it more of an inspiration where the NIR says, well, we're using some of the calculation that you have in the model, but ultimately we set up the model in a completely different way. So this is a thanks to all the people that have helped us with the model in the past. That QR code gets you to the GitHub page, and if the GitHub page doesn't give you the answer that you're looking for, there's also our email to contact us. And with this, I stop and would welcome any questions, or for Doug to jump in and tell me that I'm like completely off to lunch or somewhere else.
Yeah, thanks for that presentation, Roland. Irina, I know we're right at the lunch break, but I'm assuming we can accommodate at least a couple of questions and then maybe start a little later if that's all right with the rest of the group. Okay, well then please, if you have any questions for Roland, please go ahead and come on camera and unmute yourself and ask away.
Yeah, I should mention that we likely do have a postdoc gonna start with us beginning of May that Irina was so kind to provide funding for. Diego told me we're just waiting for the signature from the UFT, and then this can go ahead. And so the work that then will ensue is basically that the postdoc would take a look at the database we have, the publications that we can find, and basically do a form of meta-analysis potentially on them to see what management practices we can crystallize out, and that itself could then be a publication that would be valuable to Doug. As well, then I'm already kind of keeping my ear out for people that would like to collaborate basically on the interface design, on like how this would then fit into the model and how this could ask for information from farmer that they know how to get. Sorry, George, I'm just babbling on.
Yeah,
If I
go
may,
ahead,
actually,
George. Yes.
yeah. First of all, I would like to thank you for all the good work that you do. I found Holos very helpful. And as you probably, I don't know to what extent you were present yesterday, but we're hoping that all the modeling work across the different objectives that is put in place ultimately will inform Holos to make it more robust, to include uncertainty estimates, and so on. This is actually my question, and you do not have to answer now, but we really need to brainstorm how the different models that are being produced through this project can provide meaningful information for individual processes or collectively for system-wide estimates of emissions. I could see a very helpful interface, and even if we do not have fully all the data, even to provide outputs of mechanistic models as Monte Carlo scenarios that can be used to offer a user-specific user interface to provide specific inputs and get outputs, I think it will be useful. We have a lot of potential here.
In terms of the Holos model itself, there is technically no limitation on how complex the calculations are in the background, as long as the interface is simple enough for a farmer to use. That said, the question is, often the more mechanistic calculation need a lot more data inputs, and the question is, where will they come from? Because the farmer may not have them, and they may not be able, there may not be a method to go out in the field and take a sample and then have the number. So if there is a lookup table that gives you reliable numbers, and this goes back to Doug's soil information data tables, then great, but the likelihood is that we don't have a Canadian database that would have input data on the necessary level of resolution to go in. The second point in how far can process models inform, basically, for instance, loss factors. This is something we're currently exploring with respect to for our nutrient management as well. So the idea is basically there that a process model is being run over scale and number of scenarios, and then we can come up with emission factors for that. This is with the idea that basically, yes, we may be able to sell those to the scientific community as reliable as a basis for the inventory, but I don't think we have tested that so far. And this is again something where Doug may be more better suited to respond in terms of like, what are the opportunities to use a process model output as the basis for an NIR improvement? Because the crux of the problem is you report this back to basically the international community, and of course everything that makes you look better will be suspicious to others, because they're suspecting that you're just basically calculating your results nicely. Doug, you may want to jump in.
Well, there's also some very, very strict guidance around the use of process models now that's been released in the 2019 refinement of the IPCC guidelines that involves like how you set up the calibration validation process. And that is considerably, that adds a lot of complexity into how we use process models and why we can believe the process models when they are used in inventories, put it that way, because they are calibrated and validated effectively on a representative set of data.
For what
that
is
said,
worth, for what is worth, I think that it was a very welcome addition to introduce certain standards for process-based models. So that's not something that should intimidate us. On the contrary, it's a welcome advancement.
That said, I think the question of uncertainty of emission factors, if they are employed, is definitely also of interest to the NIR.
Using
Irina,
models as validation.
yeah.
Yeah.
Irina, you had your hand up earlier.
I did. I'm just keeping my eye on the clock though, and thought I might save them for you. But if you would like to hear them, it's all about the simplicity versus complexity of the approach of integrating wetlands. It's also about your cartoon and something that David raised. We've had like open discussions about what is a wetland. Does it include the riparian area or not? And I think the outcome was it does not in some of the definitions that we were using. And when I look at your zones of the wetland, zone 1, zone 2, and I see everything with vertical fluxes and nothing with lateral fluxes, I assume that that was just shorthand and that you really do want to look at the integration of that wetland into that parcel of land, both vertical and lateral flows. Is that right, Roland?
It merely represents my lack of understanding.
Oh, okay. And so that, well, you understand more than you give yourself credit for. But if I could just think about David Lobb's presentation, and again, some of the cartoons that he showed with the work that he has done with his research group, what happens with the ring around the wetlands, the riparian areas is hugely important. So does Holos allow the farmer to, like, if they adopt certain BMPs, do they get credit for that somehow? Like, can you just tell me, and I know that you also talked about the economic valuation of using the Holos for the farmer. Could you just explain that a little bit more for us, people
Right.
who are just coming to the plate?
Right now, what the Holos model is basically an education tool to inform farmers about the consequences of their decision making in terms of things that they cannot actually observe, which is greenhouse gases. I do see that the same potential for the wetlands, but I would be, and I've talked with Pascal about this previously, that the same type of setup of the system would also allow it to potentially provide some outputs on biodiversity likelihood, which is also something you, depending on your environment, you may see the consequence of your decision making, or you may not, because the bird that nests on tree X doesn't show necessarily up on this tree and nests there, but it may. In terms of regulatory approaches, we're probably, so to say, in the lucky situation where the Holos model has not been adopted for such. And in fact, say the carbon credit protocols that came out from ECCC made it quite clear that they wanted to have like a boundary between the two things, which I'm happy about, to say, because it makes our life a little bit easier. That said, because we are open source, there is an algorithm document that is going to be published as an AFC technical report, and we base things on publication. Anyone who would want to implement the regulation could go there and basically find everything ready and laid out to say, okay, that is the basis on which we do this. It also provides the opportunity to say everybody could potentially contribute to this and improve it so that before it becomes a regulation, it actually is as good as it can be. Or once it is a regulation, you can still basically use this platform to say, oh, no, we could actually make this better. And we could inform then the regulator back to say, hey, look, there's actually now an improvement here that works a lot better than what was there before. So in this context, we're probably more of a network node at this point to try and bridge basically between what is the government doing, what are policymakers doing, what are the options and necessities of the farmers, and try to provide everybody with a tool that they can use to agree potentially on what needs to be done. It's kind of, I'm stripping around your question, but I'm hoping I'm still making a point there. You're muted.
I think so. I need to reflect on your answer though.